So in the last class, we have discussed under probability distribution, random variables, discrete random variable, continuous random variable, probability mass function, probability distribution, expectation of a random variable, that is mean, variance, and a standard deviation. Now, those are all for what? Discrete random variable. Now, let us discuss for the continuous random variable. Probability density function. Now, what is meant by a probability density function? A function f of x is said to be a probability density function of continuous random variable x if it satisfies first condition. F of x must be greater than or equal to 0 for all x belongs to R. That is for the values of the random variable x. And integral of minus infinity to infinity f of x dx equal to 1. So these are the similar conditions like for probability mass function. In the probability mass function, each probability, that is pi, must be greater than or equal to 0 and summation pi must be equal to 1. Whereas here function value must be greater than or equal to 0 as well as definite integral minus infinity to infinity f of x dx equal to 1. Suppose if the range of the continuous random variable x is restricted to open interval a to b, then probability density function will be like f of x must be greater than or equal to 0 for that interval and integral of a to b f of x dx equal to 1. Now geometrically we know that integral of a to b f of x dx corresponds to the area bounded by the curve y equal to f of x, x-axis, and the ordinate x equal to a, x equal to b. So this entire area must be equal to 1. Suppose an interval alpha to beta is a subset of the interval a to b, then probability of alpha less than x less than beta can be written as integral of alpha to beta f of x dx. Now, here alpha and beta are excluded. Now, whether alpha and beta are included or excluded, the value of the probability will not get changed. That is, probability of alpha less than or equal to x less than beta will be same as probability of alpha less than x less than or equal to beta, which is also same as probability of alpha less than or equal to x less than or equal to beta, which is same as probability of alpha less than x less than beta. Whether it is included or excluded, always we need to calculate integral of alpha to beta f of x dx only. Next, cumulative distribution function. Let x be a continuous random variable and small f of x is a probability density function. The cumulative distribution function of the random variable x is denoted by capital F of x and defined as capital F of x equal to probability of capital X less than or equal to x. That is equal to integral of minus infinity to x f of x dx. So in a similar manner, it is with respect to the cumulative distribution function for the discrete random variable. There we are using the sigma notation. Here we are using the integral notation. Now, that is if you observe geometrically from minus infinity to up to x value, the entire region area. Suppose if you are having a probability of random variable x lie between alpha to beta, this we can express in terms of cumulative distribution function as f of beta minus f of alpha. That is, f of beta corresponds to minus infinity to beta. In that you are subtracting minus infinity to alpha, then it becomes probability of alpha less than or equal to x less than or equal to beta. Consider an example. Verify whether the following function represent a probability density function. F of x equal to e to the power of minus x where x greater than 0 and 0 for all other values of x. Second one is f of x equal to x by 2, x lie between minus 2 to 2 and 0 for all other values. Also determine cumulative distribution function if it exists. That means when you want to check a probability density function, we have to check first condition is the value of f of x must be positive, and second condition is in that interval the definite integral 0 to infinity e power minus x must be equal to 1 or not, we have to verify. So first example, f of x equal e to the power of minus x is always positive and integral of 0 to infinity e power minus x dx equal to 1, and the probability density function, it is a probability density function and cumulative distribution function is 1 minus e power minus x. Whereas second example is not a probability density function because it is not satisfying the first condition nor the second condition. That is, f of x is not greater than 0 for all x belongs to -2 to 2. Also, integral of -2 to f of x dx is not equal to 1. So another topic is binomial distribution. Under binomial distribution, what is meant by a Bernoulli trial? So a random experiment is said to be a Bernoulli trial if it has only two outcomes. That is, an example is success and failure, true and false, etc. Suppose if I consider P and Q are probability of getting success and failure, then P plus Q must be equal to 1. Now, example is when you toss a coin, if I take getting a head as a success, then not getting a head will be the failure. So probability of getting a head is 1 by 2. Probability of not getting a head is also 1 by 2. That means here P equal to 1 by 2 as well as Q is also 1 by 2. If I take an example, throwing a die, getting a number 1 as success and not getting a number 1 as failure, then P equal to 1 by 6 and Q equal to 5 by 6. Now, another example is answering a multiple choice question with 4 options. Then correct answer I can consider as success. Not getting a correct answer, that is wrong answer, as a failure. Then P equal to 1 by 4 and Q equal to 3 by 4. Binomial distribution. A discrete random variable x which takes values 0, 1, 2, 3, and so on n is said to follow a binomial distribution if its probability mass function, that is probability of capital X equal to R, is NCR p power R q to the power of n minus R, where R equal to 0, 1, 2, 3, and so on n, such that P and Q are positive and P plus Q equal to 1. So here P is the probability of getting a success and Q is the probability of getting a failure. And if the random variable follows a binomial distribution, it will be written as x, capital X, similarity symbol, B corresponds to binomial, n comma P. N corresponds to the number of independent and identical Bernoulli trials. That means you are performing the same experiment independently n times. And each time the getting a success probability is P and a failure is probability Q. And P and P are only the parameters because Q is with respect to P can write as P plus Q equal to 1. Now here probability of X equal to R means getting R successes in N trials. Means out of N trials, you should get R successes because R successes can be anywhere out of N positions. Means getting R successes corresponds to NCR and each success probability is P, that's why it is P to the power of R, and failure probability is Q, that's why it is Q to the power of N minus R. That's why it is probability of X equal to R is NCR P power R Q to the power of N minus R. Now, we need to check whether is this probability, is it corresponds to a probability mass function or not. So it should satisfy the certain conditions. Each must be positive and the sum must be equal to 1. Now each value is positive when I take different values of R. So probability of X equal to R is always greater than equal to 0. And sigma R equal to 0 to n, probability of X equal to R is also equal to 1. Now, using the binomial theorem, we can write as sigma R equal to 0 to n, NCR P power R Q to the power of n minus R, which is same as Q plus P whole to the power of n. But Q plus P equal to 1. So Q plus P whole power n is also 1. So let us calculate mean, variance, and standard deviation of binomial distribution X follows a binomial distribution n comma P, where n and P are the parameters. Now, so mean, another symbol is mu or x bar. It can be written as expectation of the random variable X. And variance, sigma square. Standard deviation, sigma. So the formula for mean for a discrete random variable, sigma xi pi, that's the formula for the mean, I equal to 1 to n. Now this formula you have to apply for the binomial distribution and then you have to simplify. Sigma R equal to 0 to n r into, because the variable is r, and the corresponding probabilities, that is p of x equal to r, that is ncr p to the power of r q to the power of n minus r. So if you simplify, then you can prove this as n into p. That is mean is np. Next, variance formula. Expectation of x square minus expectation of x whole square. And you can derive this as npq. And standard deviation is square root of variance. That is square root of np. So the mean of the binomial distribution is np. Now this can be derived as mu equal to sigma r equal to 0 to n r into ncr can be written as n by r, n minus 1 cr minus 1. P power r you can write as p into p to the power of r minus 1. And q power n minus r you can write as p to the power of n minus 1 minus of r minus 1. Now, so np can take outside the sigma, then the remaining will be again a binomial expansion, that is q plus p to the power of n minus 1, but q plus p is 1. So the mean of the binomial distribution is np. So in the same manner, let us calculate first expectation of x square. Sigma r equals 0 to n r square ncr p power r q power n minus r. R square we can write as r into r minus 1 plus r. Now if you separate the two terms and apply the same concept of the previous, then we can write directly as n into n minus 1 p square plus n into p. Now variance of the binomial distribution is expectation of x square minus expectation of x whole square. That is n into n minus 1 p square plus np minus n square p square. When you simplify, you will get npq. Now, each of 5 questions on a multiple choice examination has 4 choices, only one of which is correct. A student is attempting to guess the answers. The random variable x is the number of questions answered correctly. First bit. What is the probability that the student will get exactly 3 answers correct? Second bit. What is the probability that the student will get at most 3 answers correct? Third bit. What is the probability that the student will get at least one correct answer? In this, probability of getting a success means getting a correct answer is 1 by 4. Not getting a correct answer, 3 by 4, because 4 options are there. One option only will be correct. So p equal to 1 by 4 and q equal to 3 by 4. And number of questions is 5. So n equal to 5. So it follows a binomial distribution. So the first bit is getting 3 correctly, means probability of x equal to 3. So ncr, p power r, q power n minus r. That is 5c3, 1 by 4 to the power of 3, 3 by 4 whole square. Now simplify. So the value will be 0.0879. Second bit is probability of x less than or equal to 3, which means probability of x equal 0 plus probability of x equal to 1 plus probability of x equal to 2 plus probability of x equal to 3. Apply the formula and simplify. Then the value will be 0.9844. Next, third is probability of x greater than or equal to 1. So instead of calculating 1 onwards, take from the total. That is 1 minus probability of x equal to 0, which is 0.7627. So here x follows a binomial distribution with parameters n and p. So first bit, n equal to 10 and p is 0.4. So the number of times the Bernoulli trial is performed is 10 times and probability of getting a success is 0.4. So what is expectation of x means mean and variance. Now you know the formulas of mean and variance. So apply the formulas and simplify. Second bit, p is 0.6, expectation of x is 6, find n and variance of x. N equal 25, expectation of x is 10, find p and standard deviation of random variable x. In the first bit, expectation of x formula is np, which is 4, and variance formula is npq. The value will be 2.4. The second problem, np equal to 6 and p is 0.6, so n value will be 10 and variance will be 2.4. The third problem, n is 25, expectation of x is 10, so np equal to 10 So P equals 0.4 and the standard deviation is root of NPQ, which is approximately 2.4.